Welcome back, my fifth grade friends, for our last day together and the end of our unit about fossils. Here we are, chapter 9, a new day, a new dinosaur. We're going to close out our reading today with this chapter, and then that will be the closeout of our adventure together, and your summer break will begin so soon. I hope you guys have enjoyed this as much as I have, and we'll go ahead and get started. Are you ready? A new day, new dinosaur, chapter 9. Amy traced the entire edge of the dinosaur jawbone with the tip of her finger. She and Matt had finished excavating it, and she enjoyed the feel of the smooth, glossy fossil. A blazing sun hovered over the dig site, but after the success of the morning and the return of the missing fossils, for once the heat didn't bother her. Maybe she was getting used to it. On the other side of the dig site, Tess was showing Felix and Daria how to use a rock hammer and chisel to carefully chip away the rock round several backbones they had excavated in preparation for encasing them in a plaster jacket. Matt and Amy were next in line to learn this technique, and Amy couldn't wait to mix the plaster of Paris in water. The chemical change that took place when that happened was one she'd really grown to appreciate. Crystal was sitting on the ground sketching Julian as he scraped away the last of the sandstone around the dinosaur's foot bone and they had been working on. Amy was pleased to see that Julian was back to being his normal self, and Dr. Forrester was sitting off in the shade at the far end of the plateau, happily studying the strange little bones with a magnifying glass. She announced that from now on she wasn't letting them out of her sight and was even going to sleep with them next to her cot at night. Tess stood up and tugged off her safety goggles. I think it's already time for my water break, everyone, because the heat today is fierce. Matt retrieved bottles of cold water from the ice chest, and Amy was reminded of their first day of digging and the discussion of matter. It suddenly struck her how much chemistry they'd learned since. You're pretty sneaky, Tess, she said with a laugh as they all sat down under the tarp at the edge of the dig site. We came to fossil camp to learn about fossils, and you ended up teaching us about chemistry, too. Tess smiled. So you haven't minded all my chemistry lessons? Amy shook her head. It's been really interesting, especially learning about chemical changes. I like the idea that chemical changes can turn one type of matter into another by shuffling atoms around that go on to the bond in new combinations. In a way, I suppose it's a bit like recycling, Felix said thoughtfully, staring at his water bottle. What I mean is, when we recycle these plastic bottles, they'll be remade into something new. Actually, chemical changes are the ultimate recycler, Tess replied, because they recombine the same elements over and over again in different combinations to form new types of matter. A plastic water bottle already has a long history of recycling. Felix, from a chemical change point of view, would you like to hear the story? Everyone said yes, so Tess drained the last of the water from her bottle and began. Imagine you had a time machine and you set the dial for 3 million years ago. You'd step out into a warm, humid, green world full of forests and swamps, teeming with tall trees, gigantic ferns, and all sorts of other ancient plants. Plants and plant-like organisms grew in the ancient oceans, too. All of these green-growing things, like all living things today, had bodies built mostly from compounds that contained atoms and element carbons. Because there was so much plant life living and growing on Earth 300 million years ago, there was also a lot of plant life dying. Some of those dead organisms decomposed relatively quickly. Some were buried and fossilized like achy breaky, but some underwent different kinds of chemical changes that transformed their carbon-rich remains into carbon-rich substances we call oil and coal. So carbon atoms that were once in the bodies of ancient green-growing things are now in oil and coal? Julian asked. Not all of them, of course, but a lot of them, Tess said. Now zoom forward in your time machine to the 1900s when chemists started playing around with the carbon-rich compounds in oil. They discovered chemical processes that could change some of those compounds into plastics. She held up the empty water bottle. In other words, carbon atoms that were once in the bodies of 300 million-year-old life forms became part of oil deep in the ground and are now part of this plastic bottle in my hand. Matt whistled softly and shook his head. That's absolutely amazing. Actually, everywhere you look in nature, you see the recycling of elements thanks to chemical changes. Tess reached over and plucked a blade of prairie grass from a nearby clump. Like all plants, including plants that grew 300 million years ago, this grass carries out something called photosynthesis. That's a process in which water and the gas carbon dioxide undergo a chemical change. Carbon dioxide, that's the same gas that makes pancakes fluffy, right? Crystal asked. Yes, that's the one, Tess said. In photosynthesis, the atoms making up molecules of water and carbon dioxide are recombined, using energy from sunlight, to produce molecules of sugar and oxygen gas. Plants release the oxygen into the air and use the sugar molecules to grow and build their bodies, including the parts that animals and people eat for food. So atoms of carbon, oxygen, and other elements that were once in the air or the water become parts of plants, and then become parts of us when we ate the plants, Daria said. Exactly, Tess said. But how did the carbon dioxide get into the air in the first place, Felix asks. Excellent question, Felix. Tess took a deep breath and let it out slowly. The cells of all living things produce carbon dioxide as a waste product. We get rid of it by exhaling. Then she gestured toward the fossil that lay in the rock beside them. Whenever something dies, like good old achy breaky, the compounds in its bodies are broken down and the atoms that form them are recycled. Some chemical changes that are part of decomposition return carbon to the air as carbon dioxide. You mean that when we take a breath, we're breathing in carbon atoms from something that died? Daria asked. Tess burst out laughing. Yes, I guess you are, but atoms are no different if they are in something dead or something alive. They're just atoms. Tess glanced at her watch. One last thing I'd like you to think about, and then we should get back to work. You've been working on Achy Breaky for several days now. You're getting to know him, but think about this as well. When this amazing dinosaur died, the compounds that made up his body were broken down by chemical changes. The atoms that were once part of these compounds moved on. Perhaps thanks to chemical changes, some of Achy Breaky's atoms are now part of compounds in the soil or the water or the air that you're breathing. A hush fell over the group as they stared at Achy Breaky's bones, warm and shining in the bright sunlight. Amy knew she would never be able to look at those bones in quite the same way. Felix stood up and took a deep breath. Thanks, Achy Breaky, he said. I needed that. They all burst out laughing and picked up their tools and resumed their work. Before they could even get started, however, Dr. Forrester came hurrying over. Her face was aglow with excitement, and she held a fossil in one hand and her magnifying glass in the other. I found something, she said in a voice that made them stop everything they were doing. I found unmistakable evidence that these strange little fossil bones are those of a small dinosaur. Come and look. They gathered around her as she held up one of the fossils. The key was this piece, the one that went missing right away. She pointed to part of the fossil fragment. This piece is definitely from a dinosaur skull. I can tell because there are telltale ridges in the bones that are placed where muscles attached in a unique way to dinosaurs. What kind of dinosaur was it? Daria asked. That's the really exciting part, Dr. Forrester replied. Based on the curve of this piece, it's from a very small dinosaur. At first, I thought it might be from a baby dinosaur or a juvenile, but other features that I've identified this morning are only found in skulls of dinosaurs that are fully grown. That means this dinosaur was an adult. She stopped and looked at everyone. But I've never seen an adult dinosaur with a skull this small, which means we might have discovered a new species. I'm not absolutely positive at this point, but I'm certain enough to be very excited. Wow, a new species, Felix exclaimed. That means you could be famous, Dr. Forrester, Julian said, smiling. You told me so on our first day here. That's where you're wrong, Julian, Dr. Forrester said softly. A discovery like this could mean that you're all famous. Whatever we discovered, you all helped discover it, and that means you get your names on the scientific paper that will write about this little dinosaur. It'll need a name, Amy said, taking the small piece of bone from Dr. Forrester and cradling it in her hand. It will need a scientific name like Acoraptor tematorium, she said, sounding out the syllables slowly. How about Fossilcampus fantasticum, said Felix gleefully. When they'd stopped laughing, Tess glanced at her watch again. Okay, fossil campers, let's get back to work. Tonight we can sit around the fire and talk all you want about this new discovery. But don't forget, we have a bigger dinosaur to work on, with lovely bones that need to be excavated, jacketed, and transported back to camp. Amy watched as everyone picked up their tools and resumed tasks that just a few days ago had seemed strange and new. They had learned so much and gained so many skills. For Amy, fossil camp had turned out to be far better than she ever anticipated. Who knew that digging up fossil bones under the hot sun in a place with snakes would turn out to be so much fun, or that she could use physical and chemical changes to solve a real mystery. Inspector Ellis, she thought, here I come. And with that, class, is the end of our unit. I hope you enjoyed our dinosaur unit. Don't forget to get the extra credit. There is an assignment on Google Classroom. I've enjoyed these past 2 weeks together. I hope I get to see you guys again. Good luck in middle school. Have a great summer. Dr. Beaker, out.